Hi guys, so inshallah we're gonna practice on lesson 2 of chapter 12. We start talking about the types of the chemical reaction. So simply here we're gonna just make kind of we answer the section review, which actually was your homework. Then we're gonna pass to some questions and like so. Before that, do you start guys to memorize the symbols which I already uploaded in the SMS yesterday?
Yes.
The symbols of elements. Okay, it's a little bit difficult, so I'm gonna give you one more extra day. Okay, tomorrow inshallah we're gonna use them, so please keep practicing more and more, okay, to find the process is easy inshallah tomorrow. So let's start here. Question number 1, he said that contrast synthesis and decomposition reaction using a diagram. So who can answer this question, guys? What the idea? You could just, yes, Hannah. Hamdi, yes.
Okay, we can get two diagrams or any drawings
Yep.
In synthesis we could make it into this diagram for this diagram plus this drawing equals two drawings with each other.
Okay, so could you use your pen just to draw it on the screen here? You have your right, okay? Right, okay, so.
Okay. Okay.
Yep. Okay. So this one plus. Okay, good. So, okay, and instead of equal, we're supposed to make somehow kind of
arrow.
Arrow, yes. Okay, yeah, good. Okay, so let's do the second one, decomposition. How it's gonna look like?
Me too, برضه.
Yep.
Okay. It will be the same, but backwards.
You just draw.
Okay. Here. It will be.
Okay. Brilliant, Hannah. Very good. Okay. So anyone disagree with this, guys, or have find it's not good, or okay? So brilliant. So like this here, okay, we could find that like this. Okay, we could find that's how Hannah answered the question. Brilliant. So let's try to put the answer here. So we could find it look like this. So it's simply we just gonna cut the parts which we doesn't need. So we said we need the composition, and so like this, we're gonna cut this one. Okay, and that is synthesis. Yep. So here, and that's we're gonna make a decomposition look like this. So any hard question here, guys?
No, I'm mistaken.
Okay, so let's pass to question number 2. So question number 2, a reaction in which the parts of two substances switch places and they make two new substances. So what we call this kind of reaction, guys? Who can answer this? Yes, Fatima?
Double replacement reaction.
Good, so it's double replacement. So, sorry guys, so double replacement reaction, good. Question number 3, okay. He asks here, classifying the reaction shown below to an A plus Cl2 yields to an ACl. So what kind of this reaction? Yes, Reem?
Synthesis.
Synthesis, good. So synthesis reaction. Then question number 4, write the Planted equation that produces Na and Cl2 from NaCl and classify this reaction. So who can answer this one? Yes, let's find here. What about the others, guys? Ali, could you share us? Where? Yes. What are the reactants here?
Na.
Na.
And Cl2.
No. Read the question well carefully. Right? He asks, write the Planted equation that produces Na and Cl2. So that means Na and Cl2 they are
They are the products.
The products, good. So they are the products. So while the reactants are
Na and Cl.
NaCl, it's just one compound. So it is NaCl. So here we say that NaCl, okay, that will yield, okay. So here, it will yield what? Okay, Na, then Ali, I'm waiting.
Na plus Cl2.
Plus Cl2, brilliant, okay, because we find, okay, that's here, so Cl2, okay, let's balance this equation. Is it balanced like that?
No.
No.
So let's balance it. How we could balance it? I'm just yep, let's balance it. I'm with you, Ali.
Add a coefficient.
Where we should add the coefficient? Here, where?
Before Cl.
Before Cl. Actually, how many Cl do we have here, Ali?
Oh, we have one C.
Here,
we have two.
no. Cl is chlorine, and just one element. We have two, okay?
We
and
have
here,
three.
how many chlorine do we have?
One.
So where should we add the coefficient?
Before Na.
Yeah, here. So we're supposed to make it NaCl. So like this, we have 2 sodium and 2 chlorine. But in the other side, we just have 1 sodium and 2 chlorine. So chlorine is balanced. What about sodium?
We should add a coefficient.
Yes, we should add a coefficient too. Good. Okay, yes.
مستر هو في الكتاب بتاعنا مكتوب H2O أصلا.
Where is H2O?
يعني مش NaCl H2O. Yes, number 4.
مكتوب H2 and O2 from H2O.
Write the balanced equation that produced that. Yeah, you have another question in your edition?
Yes.
We have the same one but different, but يعني H2O بدل NaCl.
So let's make it, no problem, okay? So here, let's try to do this. Okay, H2O, who could answer this? H2O, that yields?
H2O2.
So it will yield H2 plus O2. Good, okay. So first of all, we must check if the chemical equation is balanced or not.
No.
So the chemical equation is not balanced. So who could balance this chemical equation, guys? Okay. Who could balance this chemical equation? Yes, Yusuf?
We should write 2 in the coefficient before.
Before
2HO.
That's here. Where I'm gonna write 2 beside H2O or here or where?
Before H2HO.
Where is H2HO? Where is H2HO? Where is that? You explain about another thing.
Yeah, we cancel the 2 in the middle between H and O.
We put here 2?
No, before H.
Like that?
Yes.
So we say, right, listen, Yusuf, just to be able to describe, we said we write coefficient 2 before water or before H2O. Is it clear?
Okay.
Yeah, okay, so like this, how many hydrogen do we have in that side?
4.
And in this side?
2.
So what we should do?
We should remove the 2 يعني of the H of the hydrogen.
Remove it?
No, we can't change the formula.
We cannot change subscripts. Never ever we change subscript. We only balance by adding coefficients. So here we have 4 hydrogens, but here we just have 2 hydrogens.
2.
So we just are gonna put 2 here. So like this we have 4. Okay, so here 4 hydrogen, 4 hydrogen. Here we got 2 oxygen, and here 2 oxygen. So it's balanced. Yusuf, we never change subscripts. We only balance by adding coefficients, and we never remove. We don't remove anything. Okay. We never remove anything. Okay.
Okay.
Okay, guys, question number 5. Let's find here. So classify in which two, okay, so he asked in which two groups of reactions can this reaction be classified? So yes, Fadia? Fadia? Fadia, could you answer question number 5? Do you have the same question in your edition or it's different, guys?
Yes, the same one.
The same.
The same.
So in which two groups of reaction can this reaction be classified? So, yes, Fadia. Just raising your hand without answer, okay? So Judy?
Synthesis.
So synthesis, actually synthesis. So that's good, yep. So we're going to just synthesis. He asked in which two groups of reactions, actually we're just, it could be classified to one group only, which is synthesis. There is no other group. Actually, sometimes they can write combustion because it's reaction with oxygen, but actually there is no rise of energy, okay, here. So in that case, we cannot, okay, ensure that is as a combustion reaction, but just we could say synthesis and combustion if you want, but I prefer just to classify it as synthesis reaction. That's more, okay, accurate and that's more scientific, okay? Is it clear here, guys? You get it?
Yes.
So let's pass to question number 6. Question number 6, he asked you, let's see here. So here asked, complete the table to identify types of the chemical reaction as shown in the table. So here he said synthesis, at least 2 reactants and 1 product. So what about the others who can tell me? What about the others? Guys, please raise your hand in chair. Rashwan, could you tell me what about decomposition? Okay, Shwan. Shwan, can you hear me? I don't know. Rashwan, could you tell me what is the pattern in which the decomposition follows? So how the number of products and reactants and so on, or what happens in that kind of reaction? Okay, Lujaina?
Okay. Decomposition?
Yeah.
Okay, one compound break down and forms two or more substance.
So one reactant break down into at least 2 products. Good. Okay. Then the other one.
Complete?
No,
okay.
no, just one enough. Okay. So then here after this we have single replacement. Who can tell me what happened in single replacement, guys? Okay. Yes, Kinsey.
A is a one element that replaces to another element in one compound.
So one element, good, replaces another element in a compound. Good. Then double replacement. So who can tell me what happened? Yes, Usama.
2 elements replace each other, forming 2 new compounds.
So 2 elements in 2 compounds replace each other, producing 2 compounds. Okay, so okay, guys. Then past question number 7 here. Okay. So question 7, he asked you design a poster to illustrate single and double replacement. So it's the same idea like the first one. Okay, so we're just gonna say it's look like this, so we'll not repeat it one more time. So then pass to question 8. So infer the combustion. Okay, infer the combustion of methane produces energy. Where do you think this energy comes from? Okay, so what do you think, guys? So here he said that combustion of methane. What methane is burning? That's methane reacts with oxygen. It will produce carbon dioxide, water vapor, and energy. So what do you think? From where does this energy burn or produce? That's a good question. Yes, let's see who can answer this question, guys. Try to think. Sure, guys. Maya, could you help us in that question? Maya. So 2 marks bonus for that question, guys.
still هو Maya she can't her internet connection is
okay.
yes.
So anyone could help me in that question? 2 marks bonus. We said that once the combustion of methane done, it releases, or combustion of whatever, so it releases energy. So we asked from where does this energy come? So who can answer this question? Okay, let's see. Yes, Rashwan.
هو number 8 صح؟
Yep.
Okay, because the energy is stored in the chemical bonds that hold the carbon and the hydrogen atoms.
Again,
And,
because the energy again, because the energy you said.
What?
You are talking well. I can't hear you again. Just we said the energy.
The energy is stored in all chemical bonds that hold the carbon and hydrogen atoms together. And when the atoms are rearranged, the bonds are broken.
Yep.
So they release energy.
Good question. Good answer. Thank you. Okay, Rashwan. So, okay, 2 bonus for you, Rashwan. And actually, let's see here. So we said he asks how this energy come from. Simply, we know that any chemical reaction, reactants, methane will gonna break down the bonds, and then it will rearrange to form new bonds. So the new bonds which are formed in the products, actually they are less energy than the bonds which is already was in the reactants. So this difference in energy is released as a form of heat or whatever the energy is. You get the idea, guys? Is it clear?
Yes. Yes.
Okay.
Yes.
So we said that due to the difference of energy and the bonds in reactants and bonds in products. So, you know how the question regarding this guy part, guys, or it's easy?
Easy.
Okay.
Easy.
So now let's pass to the next. Let's try to find the kind of practice here. So let's try to do this together, guys. In this image, shapes are used to represent the chemical reaction. What type of reaction is represented in that kind? So just raise your hands. Okay. Let's find here. What about Adam? Could you help us in this case, in this question?
See?
Who's talking?
Adam.
So yes, Adam, you said it's C. Yeah, good. Okay. That senses. Do you agree, guys?
No.
No. So Adam, have another try. It's not synthesis, because synthesis actually 2 substances combine to produce one, but here that is the opposite. It's just one compound break down into 2 substances. So what is that, Adam?
B.
B, it's decomposition, breaking down. Okay. So question number 2, sulfuric acid H2SO4 is produced by reaction between water and sulfur trioxide. What kind of reaction is this? What do you think, yes, Fadia? Fadia? Fadia, are you here?
B.
So B. So if it's single replacement, what replaces, which element replaces the other? Let's see, sulfuric acid, H2S4 is produced by reaction between water and the sulfur. So let's think together, Fadi. Where is the product? Fadia?
H2.
Yep.
SO4.
SO4, that is the product. So we have this product. There is another product?
No.
No. So what are the reactants?
H2O.
And?
SO3.
So we have two reactants that produces one product. So what the kind of reaction?
يبقى double replacement?
No. Simply look with me carefully. He means, okay, you said we have two reactants. H2O is going to react with SO3. Finally, they are going to produce H2SO4, yes? So what this kind of reaction? Two reactants just producing one product. Yes, Usama? Usama?
A, synthesis.
A, synthesis. Water combines with sulfur trioxide to produce sulfuric acid. Is it clear, Fadia?
يعني there is no replacement في الموضوع?
No replacement, they just combined. Replacement that I should find, there is someone is kicked out. But here they just combined. The pattern in, hey, remember always the pattern, okay, that the single replacement takes, or the single replacement reaction, like for example, when we say K reacts with Na, okay, Cl, so K is more active than Na, so it will replace it, so it will be KCl plus Na. So in that case, that's kind of replacement. Here we find an element plus compound produce a new compound and another element. You get the idea?
Yes.
Okay. So here like this, let's pass to the next, guys. Question number 3. In which type of reaction do the negative ions from two compounds switch places? Jay Norman? D, double replacement, good. So here, what type of a reaction is presented by the following equation? 2AgNO3 plus Cu yields Cu and L3 by 2 plus 2Ag. So what are these, guys? What we call this? What kind of reaction? Yes, Nano?
Double replacement.
Where's double? Where's the other compound? So think that is a compound. Okay, AgNO3, that's silver nitrate, it's compound. Cu, is it a compound or element?
Element.
So a single element, copper, replaces silver.
يبقى
so,
single.
Yeah, that's single replacement. Okay. Last question, which is not a product of combustion? What of these not considered to be a product of combustion? Yes, Reem?
B.
B? No, we said that combustion reaction always produce. I can't hear you.
B.
No.
I said B.
No. Okay.
No.
No. Okay, this is Jane and Amal.
C.
C. Because combustion reaction, it is the reaction with oxygen that always produces, okay, carbon dioxide, water vapor, and energy. So energy, water vapor, and carbon dioxide, they are the results, okay, they are the products of any combustion reaction. You get the idea? Is it clear, Reem?
Mister, I have a question.
Yes, of course.
Mister, best can we go back to number 3?
Going back to number 3, okay, of course.
The number 3. It said that negative ions from two compounds.
Yep.
One
one I.
Let's
One I.
see. No. Let's see. Okay, so for example, here, let's take an example. Once we say NaNO3, that's where we act, or sorry, just let's make it NaCl, that where we act was AgNO3. Okay, so as we said, any compound, as we said before, that any compound is made of two parts, the positive part and the negative one. Do you remember?
Yes.
Yes. So here, this part represents the negative ion in that compound, and that part represents the negative ion in that compound. So let's switch places. Let's take the NO3, take the position of Cl. So what the result will be? It will be NaO3. Yes? Plus
okay.
the Cl will take the position of NO3, so it will be AgCl. You get the idea? So it's a double replacement.
Yes.
Because simply in double replacement, they are gonna switch places. Whatever the negative ion or the positive ion, they are gonna result in the two new compounds. You get the idea?
Yes.
Okay. So anyone have any question, guys?
No, thank you.
Everything is clear?
Yes.
So don't forget to memorize the symbols, okay, which I already provided to you in the SMS. You must memorize it very well. Tomorrow, inshallah, we're gonna practice about how to write the chemical formula of ionic compounds. Thank you, guys, and goodbye.